All right, so we're interested in solving these quadratic equations. And as mentioned in the instructions, we want to use factoring to help us solve the quadratic equations. So to do this, we want to make sure that we're in the standard form. And this is addressed at the very beginning of this section. So you might want to refer back to the textbook where they mention how to put it in standard form. But as you can see, if you review the standard form, that that part A is actually already in this form. So the standard form, just a little reminder, I'll put it up here, is in the form ax squared plus bx plus c equals 0. Some slight other criteria that they mention in the textbook about being in the standard form. At least for a quadratic, a cannot be equal to 0, because if a is equal to 0, then you don't have a quadratic equation. So anyways, moving on, we have part A, and we're interested in solving the quadratic equation. And so we want to factor this first. So we're going to factor the left side of the equation once you have it in the standard form. And then eventually we're going to be using the zero product principle, which is mentioned on the top here. And I'll show you where we'll be using that principle. So if needed, you may want to refer back to how to factor, but which was discussed in chapter P. But let's go into this. We'll see that we have negative 15 for our constant term, our C term, and we want to factor this negative 15 so that it adds up to positive 2. So we notice that this could be 5 and negative 3, and we add these together, 5 plus a negative 3, we get 2. So that's exactly what we want. We want positive 2. So we know that this breaks down into, this factors to x plus 5, x minus 3. And that's equal to 0. And still equal to 0. So what we've done, if you just focus on the left side of the equation, see how we factor it into this, and we ignore the equal 0, it's just like factoring. But so that's where we use the factoring to solve this equation. Now at this point, we want to use the zero product principle, and you'll see how this is how the zero product principle is used, because what this is saying is a and b are algebraic expressions. As we can see, x plus 5 is an algebraic expression, and x minus 3 is an algebraic expression if you look at those individually. And these two are being multiplied together. And that's what this is saying. If a and b are algebraic expressions, just like x plus 5 and x minus 3 individually are algebraic expressions, when they're multiplied together, just like how these are multiplied together, and they're set equal to 0, then, assuming you have that true, which we have, then you can set each of the algebraic expressions equal to 0. So we can set x plus 5, the first algebraic expression, equal to 0, and x minus 3 equal to 0. Just separate that. And so the reason we can do this, just to explain the zero product principle a little bit, if you think about, if we know that the product of two numbers, if you just think of numbers, if you know that the product is equal to 0, the only way you can multiply two numbers together to get equal to 0 is if one of the two numbers at least are equal to 0. So, for example, think of two numbers being multiplied together, like 1 and 3. That's equal to 3. And there's no way you can multiply two numbers that are non-zero, both are non-zero, to equal 0. One of those numbers has to be 0 at least, or both of them. So you can have like 0 times 3 is equal to 0, or 3 times 0 is equal to 0, or 0 times 0 is equal to 0. But either way, you must have at least one of those two numbers be equal to 0. So that's why we can set each number equal to 0, because that's the only way you can have the product of two things to equal 0. Anyways, that's just explaining the zero product principle a little bit. So we have x plus 5 equals 0, and we can solve this equation, and we get x equals negative 5. And then we solve the other equation, and we get x equals 3. Okay, so that's our two solutions. And it's a good idea to check your solution. So I would suggest that you do that. Check your solutions. It's not required here. There are cases where it is required to check your solutions, but this isn't a place where it is required. But it's a good habit to always check your solutions. And so, for example, I'll show you how to check x equals 3. Or I'll do -5 since that's the first one I found. And you would want to plug -5 into the original equation where you ever receive x. So x -5 squared plus 2 times -5 minus 15. And we want to see if that's equal to 0. We want it to be equal to 0. So this is equal to 25. -5 squared is positive 25. And then 2 times -5 is -10 and minus 15. And we see that 25 minus 10 minus 15 is equal to 0. Good. And x equals 3 should check out too. But you should check all solutions. All right. So let's go into the second problem here and do that really quickly. Okay, so we have, and remember, we want it in the standard form, ax squared plus bx plus c equals 0. So everything set on one side of the equation, and the terms are in descending order. So we have 2x squared minus 5x, and then we want to subtract 12 to the other side of the equation. And now we're in standard form. Now, you may remember how to factor when your leading coefficient is not equal to 1, like part A was equal to 1. But when it's not equal to 1, we have 2 here as our leading coefficient. And in this case, if we want to factor this, we want to use, you can use the AC method, which isn't actually introduced in the textbook, but I do show you how to use the AC method before. I really like that method, but they also have the guess and check method, which they have you do. I'm going to go ahead and use the AC method. I really do prefer that. So 2 times -12, the A and the C, multiply those together and we get -24. And we factor that and we want it to add up to -5. So what we'll see here is that, well, we can go down the list and see what works. And we know that we want -5, so the bigger number must be the negative number. So we can have, let's see, -12 and 2, that adds up to -10. That does not work. So then we can go down and do -8 and +3. That multiplies -24, and we see that adds up to -5. Okay, so that must be our numbers. So we can break it up into 2x squared minus 8x plus 3x minus 12. So -8 and +3 gives us, we'll split that middle term up into -8x and +3x. And the the x squared term and the constant term stay the same, as you can see. Just that middle term changes. And then at this point, we can use the grouping method, which is a method I showed you before. And we can factor this to 2x and then x minus 4. And then factor the 3 out, so that would be plus 3, x minus 4 equals 0. And then we get 2x plus 3 and x minus 4 equals 0. And then again, we're going to use the zero product principle. As we can see, we have an expression multiplied by another expression equal to 0. So we can set both of those expressions equal to 0 and solve. And so we get 2x equals -3. And then x equals -3 halves. And then from this, we get x equals 4. So it's a good idea to circle your final solutions. I'll just emphasize that, and I'll circle my previous solutions. And again, always check your solutions. It's a good idea. You don't have to, but it's a good idea to check your solutions. All right, let me know if you have any concerns. I'll be more than happy to help.